have the remote control, so.
Okay, thank you. Okay, thanks. Good evening. I'm gonna speak English tonight because my Spanish is very is not very good. Okay, thank you first of all for inviting me today. Today we started with open source. We'll end last lesson with open source. I don't know if some of you knows NTOP. This is a project, an open source project that I started personally 25 years ago. And over the time, it has changed as many things in life. But the goal is still the same. So in essence, to monitor network traffic. Here today, we are talking about traffic for mobile operators or for fixed operators. So for people that bring a lot of traffic that do not belong to them, but belong to their customers. So I'm trying to focus on that. So first of all, let me give you a short presentation. As I've said, I created this open source project NTOP in 1999, and so many years ago. And there is a link here on GitHub, so if you want to have access to the source code of the tools that I'm gonna speak and present today. I don't code just for NTOP, but you know, our tools have been integrated in various other open source tools. You probably know Wireshark, Suricata. In addition to that, I give lessons at the University of Pisa that is probably less prestigious than Barcelona, but I mean, the goal is still the same, computer science. Okay. Let's go to the topic. I'm going to talk about network traffic monitoring. So I'm not going to talk about the monitoring of equipment, SNMP, this type of things, but I'm going to speak about the traffic that is flowing inside the link that you know you have. Okay, and we are now focusing mostly on high speed. Okay, today we have seen 400 gigabit, 100 gigabit as a standard. So we need to cope with speed. So we need to be precise, but at the same time to be fast. This is very important. And the tools I'm going to present today are homegrown, so I mean we have developed, and they are open source, so you can find them on GitHub. So today I'm going to share with you the experience that we have made over the years monitoring the traffic, in particular this type of traffic that you know you have on your network. Okay, let's start from the beginning. So when you have you know a fast internet link, the first thing that you need to care about is to protect yourself. So you don't care too much about your customers, but you care mostly about you. So you want to make sure that your traffic is okay, and it means that the network stays up. The first problem of this type of network is that you know, if you have denial of service, DDoS usually, this is the main problem because all the network will collapse, or most of the network will collapse, or some of your key customers will collapse, and this is going to be a big source of trouble for you. So you want to make sure that this will not happen. So I believe that most of you, if not all, have a DDoS mitigation system. Mention one, doesn't really matter, so at the end the story is always the same, to keep the network up. In this case, if there is an attack, a volumetric attack, I mean, there is somebody that is going to stop the attack on your behalf and try to let the legitimate traffic go in. Unfortunately, this is not always the case, because as the faster is becoming faster and faster, the algorithms for doing that have to be rudimental because they cannot really go deep into the traffic and to check exactly who's good and who's bad, supposing that you can do that, because most of the time the traffic is spoofed, so you don't know who's legitimate or not. So this is already a problem that is somehow solved. And then you want to understand the traffic that how it moves inside your network, so at the routing level, autonomous systems, just to understand how the traffic is flowing, if you have to make other bidding contract, this type of things. And the last thing, you have to understand how your device is behaving. So namely, if interfaces are going down, going up, or if there is something that is changing, BGP is flapping, this type of things. But I think you already have solutions for that. I don't need to explain you more than that. Instead, if you are a company, if you are a service provider, for instance, you care more about the services you are running. While in an ISP or probably in this university, most of the problems are becoming big if they expand. Here, in this case, they have customers and want to avoid the degradation of the network. So, for instance, for simple things, even email that should be, you know, consolidated. We have email since 30, 40 years. I don't know, a really long time. The problem of spam or the problem of not having a reliable service is still becoming a source of concern because your network reputation can be degraded. So you want to avoid that. So you need to somehow try to address those things. Cybersecurity is another problem. Okay, so as I've said, while you want to keep the network up, you cannot completely clean up the network. So first of all, it doesn't mean that you can stop completely at DDoS. It doesn't even mean that you want to stop attackers. But you want to stop the big attackers, those are creating a lot of trouble to you. So you have to take the big fishes to make sure that they don't create too much trouble, and you want to leave the network somehow operational. For instance, in a public university, I'm sure that you don't want to lock every student into their, their PC, their small home network. But they want to make sure that these guys can use the network. They can make little trouble, but not too much. Okay, but at the same time, the network has to stay up, because this is what a research network has to be, from our point of view. So in this case, you have to quarantine also that are in trouble or that are starting to create big problems. So it means you have to look at what is the traffic of your network. And block suspicious activity that are becoming important. So over the years, we have seen many things. And I very like this picture that is from Switch, where they say, okay, over the years, many things are changed. And now what we want to do, we want to anticipate. I mean, anticipate means that I want to do today a certain action that will allow me to be safe and that will prevent me from having problems later, okay? This can be a bit challenging, okay? But we have done, over the past years, many other things. We have put the firewall, we have put the DOS, we have done many things, and now this is our challenge, okay? So to make sure that we are able to do that. And as I've said, mitigation is a problem that has already been solved, but on the other hand, when you are at the low end, so when you have an attack that is not too big in speed, let's say 1 gigabit or so, they are not usually mitigated. So namely, there are many troubles that can happen even though you try to do your best for the big guys, okay? So that's why you have to reduce pressure free on firewall, on equipment, or in terms of licenses you have to pay for the number of sessions that are passing through your devices. So you have to block these guys. So in order to do that, you have to look at your traffic. That's why more than 12 years ago, I started with this project. This is an open source project called NDPI that allows us to inspect the traffic in the packet inspection. Probably this concept is famous because there are some companies, Palo Alto Network, and for instance, just to mention one, that have used for a long time, okay? But the problem of the packet inspection is that we have to go deep into the content, okay, the content of the packet. And while most network equipment are switching traffic, so namely they look at the beginning, the 5 tuple, the ACL, and they decide if it has to pass or not, here we have to block the traffic based on the content. Or we need to give visibility, complete visibility, with the packet inspection and encrypted traffic analysis. Because today, 80% of the traffic, more or less, is encrypted. It's going to be more and more encrypted. So we need to understand what is happening. Sometime in your network, I receive inquiries from users that say, okay, I have this link, but I would like to know what's inside this link. Because NetFlow does not tell me too much. SFlow, it tells even less. So we need to understand that. And because of the speed, probably you don't want to monitor the whole network, but you want to monitor a selected network like the data center, where certain things cannot happen, or you want to have, let's say, complete visibility. For this reason, we have created this toolkit, and at the beginning, the project call was just to classify traffic. Say, this is TLS, this is Netflix, this is DNS, simple things. But over the years, we have added something called risk, okay, flow risk, that allows us to go inside the traffic and produce a bitmap, as this is a bitmap, of common problems that you might see in the traffic. A very simple thing is that you have your TLS certificate that is expired, or you can have very malicious, more malicious things that can happen, let's say a crawler bot in your network, or you have traffic that should not be encrypted that is encrypted, or you have anonymous VPNs, these type of things. And these are coming as an add-on, okay, to DPI, and give you also, in terms of severity and score, what is happening on it. So for every problem, we assign a numerical value based on the severity. And so for this flow, you can have a number that represents the problem. And some time ago, people said, okay, today we have 100 gigabit. How can you do the packet inspection at 100 gigabit? So we have demonstrated that it's possible. Okay, this is an example of things that we did some years ago. You can take a state-of-the-art network card, like a Mellanox NVIDIA or an Intel. And it's possible to do this at 100 gigabit. So we have efficient networking software. with smart things, it's possible to do that. In particular, because for deep packet inspection, you need to look at the first packets of a connection. You don't need to look at the complete flow. Okay, once you have seen the very few packets at the beginning, this is enough. Actually, we are now creating a new type of technology called first packet classification that allows us to classify the traffic at the first packet. This is very important because in essence, we rely on previous communications. And so we know, if you know that when talking from this machine to this machine over this port means Netflix, it will be Netflix. So I don't have to inspect all the following packets, but I just have to keep this into the cache and remember for the future. And this is very important for operators or for people like you that want to switch traffic or want to block traffic at the first packet, because network devices can block packets very easily with an ACL, but they have big troubles to block them, afterwards, to put rules in memory that are overloading that. And this is an example of ETA on this open source software called NetOpenNG. So it displays for every flow the problems that we have reported, and it gives the sum of the score of individual problems and give the total score. So just to give you an idea of how bad is a certain flow. And this is very important, as I've said, but it's not enough today. I mean, we would like to go even further. So one of the things that are happening today are these that I'm going to explain. So basically in 1980s, more or less, IP-based rules, so ACL, were created, okay? Layer 7 protocols called 2011, probably even less, as I said, Palo Alto Nexus, just to mention one. But then in the last 15 years, okay, something has happened. So we need to do some sort of evolution. And the main evolution today, from our point of view, is something that is called traffic fingerprinting. So in essence, to create a somehow unique fingerprint, or at least with very limited false positive in the traffic, to try to match the traffic at the very beginning and to block it first. Remember the thing I've said before, anticipate. So we should anticipate. I don't want you to speak with me and send me the virus, but I want to stop you at the very beginning because I know that from your reputation, okay, this is a bad thing. And fingerprinting I've created on the first few packets, okay, and we want to block attackers before they inject, okay, the malicious thing to us. And this is very important. Let's make some example. So we have supported fingerprinting in NDPI of VPN, mostly anonymous VPN. Anonymous VPNs, okay, even those based on OpenVPN, are just a few of them. But there are many others that are creating a lot of trouble, in particular because they are breaking the security rules you have put on your network, because they are trying to circumvent them, this way. Or for instance, we can block malicious quick or TLS-based applications, simply looking at the fingerprint of the initial few packets. Another problem that can be blocked very easily is a bot based on SSH. So most of the time when you have an infected machine, you have this bot to which remote machines are attacking. So if you can block this looking at the SSH, because from the score I've shown you before, you can understand whether there are machines that have a certain problem. If you identify them, you identify also the fingerprint, and you can use the fingerprint for blocking those machines. Blocking when? When they send you the first few packets, when they contact you at the very beginning, when there is the SSH handshake. So you break the handshake because you block it immediately as you see that. Okay, you can do many other things like cryptominer or unwanted crypting protocol. This is not the problem. So in essence, we need to be here today. So we need to create something new. And something new is not the UTM next generation firewall I mentioned before, not even packet filtering from 1971 or layer 7 from 1993. So we need to go beyond that. We need to block the threat as soon as they happen, okay? Or when the first few packets have been sent. Just to give you an example, these are two types of attackers, okay? They are scanners. One is ZMAP, this one is MASCAN. I believe you know them, right? So if you look at these packets, it's very easy to see that there is something wrong with this packet. Can you spot the problem here with this packet? These are SIM packet. So the first packet of a TCP connection. Can you spot what is wrong here? So they're trying to inject traffic as fast as possible, and if they see a reply, they know that you're alive, so they mark, you're alive, you're alive. what's wrong with this packet? So this is the first packet, and you can block it at the very beginning. They don't have to continuously speaking with you. Look at the bottom of the packet. What is missing here? What should you should see here? No, this reflex. This is one option, like the negotiation, the standard negotiation of TCP. Okay, so these are missing, and they don't send them because they don't have time for that. So they simply inject a packet. They expect somebody replies back. So if you see a packet like this with nothing at the bottom, for sure is somebody that is doing something bad to your network. Okay. In particular, these are two examples. One is mass scan, one is ZMAP. They are used for reconnaissance, so to understand who's alive, and as soon as it's recognized, they attack it. Okay? So you can see this is a typical example of a fingerprint of the initial first packet of a communication that can be enough for blocking it. So it's not a lot of traffic, they see, again, unless you have a SIM flood on your network. Usually it's not a lot of traffic that can be used to anticipate the problem. If you want to do something more sophisticated, you can analyze the behavior of the traffic, like looking at the hosts that are contacting too many NTP server or the usual stuff you do in your network. But for this, you need more traffic to be analyzed. So that's why fingerprinting are very helpful, because they don't push us to do this type of detection that cannot be done on the backbone, but can be done on the side of the network or on the central part of the network, but not for sure at 400 gigabit, because it will be too much. And based on the score, on this number that is set next to every flow whenever there is something wrong happening, and if you sum the score and you put them on this picture, that is a bubble chart, it's not rocket science. So if you put here on the X, the score as an attacker, the score as a victim, and you have this bubble bigger depending on the issue, in this case of the score, you will immediately see that the hosts that are far away from the origin, so they are far away from here, they are either being attacked, victim, or they are attacking, so the attackers. That's very easy. So even if you take a little bit of traffic, you can really do that. And if you divide this in the network, so you put this, you have your own networks that belong to your company, and you divide the traffic in networks, okay? And if you depict them, you can see where you have the problem, most of the problems. Okay, in what part of your network you have those issues, so you can focus on that. You can drive your execution or your analysis towards those places that are somehow the source of trouble. And sorting per system can give you an idea also who's creating the trouble to you, in case it's a source or destination score, very easily. So you can understand if your trouble is coming from a certain autonomous system towards you, or if you are creating problems to somebody else because somebody in your network is creating the problem that is then propagated. Another thing that not many people are considering is the following. First of all, you have to know your network, okay? And you believe you know your network because you have seen on the previous presentation, you know where you have put the cable, you know this connected this router, this is routing, this is this is that. Okay, fine, this is the network, great. But then we have the services. Many times I see that people don't know what services they are running, don't know how computers are talking each other. This is a simple picture. Again, even this is not rocket science. So we are filtering traffic based on a protocol, SMTP. And we are putting a link, okay, towards machines that are speaking SMTP. So these are obviously SMTP servers, okay? In every network, unfortunately, most of the time, there are SMTP servers that are not supposed to be there, okay? And this is a big pain, in particular for service provider, probably not for carriers or for big company, but for sure for a university, for a big network like this, is a problem. Because those machines are impersonating services. So imagine this picture not just for SMTP, but for another type of protocol, probably a malicious protocol. Okay. In Italy now we have the problem of people watching illegal streaming content. Okay, so translate this more or less to another protocol, so change the drop-down menu and select another one, because DPI can allow you that. Imagine, for instance, a VPN, anonymous VPN. So who's talking to who's doing crypto mining? So this is very important. This is another important thing that you don't know about your network unless you look at the traffic. unless you try to understand, for instance, typical metrics that such as the number of edges. So how many hosts are talking to you or you're talking to others. That is very useful in this type of analysis to identify the machine and to identify instead the network that is creating that. Just to complete, a few words about artificial intelligence. Everybody's talking about that, so I have to give, spend at least a few words on that. How can we put artificial intelligence into the picture? AI is something that is very promising. From a point of view, is 90% gossip, or let's say advertisement, 10% substance, but artificial intelligence is happening, and it will be stronger and stronger. So my question was to myself, how can I use it? How can I use this one to improve monitoring, to improve visibility? Because here we are talking about network visibility. Let me show you this picture. In this picture, this is a simple picture that describes here there are two fingerprints. So the first one is the TCP fingerprint, so okay, that identifies the operating system of a certain machine. So this allows me to understand, again, it's TCP based, so it doesn't work with UDP. For UDP, we need another one. So it allows me to understand this machine, okay, is running a certain operating system. Others are running another operating system. Of course, we have a mapping between the fingerprinting and the operating system, okay? But I don't care about the operating system. This is very important, for instance, for me, because if I see a machine with various fingerprints, different fingerprints, this machine cannot be a single PC, but can be, for instance, a NAT. So probably on my network, I have machines that are not behaving as I expected, because they are doing other things. This fingerprint, instead, after the dash, is the TLS fingerprint. So TLS and quick. So let's take it and let's put it in this table. As you can see, this is an iPhone. I took an iPhone, I made an experiment, and I took the traffic of this iPhone. As you can see, the fingerprints are collapsing together, okay, some traffic. So have a look at this traffic. Again, it's an iPhone. So look at this, for instance. This is domain name, apple.com, Spotify, cdnapple.com. Or look at other traffic, TikTok, okay, TikTok CDN. There's also some Snapchat, so probably Snapchat and TikTok have something in common. And there is this TikTok, okay? So some services, like I said, apple.com or cloud.com, they are kind of standard. I mean, they're part of the operating system. So whenever you want to receive a notification, okay, or on your machine, on your application, sorry, you're not using a fancy protocol, but you use the system services. If you have an Android, you will have something similar, but instead of apple.com, it will be googleservices.com, something similar. So I took this example with traffic that you know. You have heard of TikTok, right? So, but suppose that you have in your network some traffic that you don't know, and you want to classify it. Because those classifiers are great, but for traffic that is known. But when you have a trouble, sometimes the trouble is coming from traffic that you have never seen before, that is talking with hosts you have never seen before, that you would like to classify them. And you would like to understand, this unknown part of my traffic, is it a problem or not? So you have to classify. I mean, TLS analysis, as I've said, is done with the mechanism I showed you before, but they have domain names. So how can I classify them? So I know for sure what is TikTok, but probably there are other domain names that you would like to classify yourself, right? So there are services on the internet you can buy for classifying companies, but they classify Microsoft, they classify Apple, they classify these big guys. But then you have new traffic that you have never seen before. So how can AI help me? So fingerprints, again, are used to cluster together traffic at the application level. The same application have various fingerprints because the same application can have various components, but I would like to classify the traffic. Let's have a look at this example. So some of you have probably used Mistral, okay? That it's a popular model. So you ask to Mistral who's ESNOG, okay? And Mistral said something about profit organization, blah blah blah, used to provide DNS services to Cuba. Is it true? I don't know. I don't think so, right? So Mistral was wrong. So using LLMs for classification, I proved it to be correct for domain names that are known, for the big domain names that are known, Apple, Facebook, this time, But for other type of domains, I'm not saying that ESNOG is not so popular, but I'm saying that it probably was not used by Mistral. That is yet it's a big domain, it's a big model. So I said, how can we use LLM? A typical way that we are now trying to use LLM is the following. So instead of relying on the classification of the model, that might be wrong. In essence, the category was right, okay, but the content was totally wrong. So I don't know exactly if it was by chance well classified or wrong. Okay, but for sure, I will not bet on Mistral. We have done something different. Okay, suppose that you have a problem. So if you look at the previous picture, you have some domain names. Again, this is an example of TikTok, but forget TikTok for a second. Imagine that you have a domain name that you don't know, okay? What a network operator does, usually, look at the domain names, if they have a network visibility tool, opens the browser, and try to classify the domain by hand. But now we have LLMs. So this is an example. Again, it's not yet ready for the prime time, but it looks very good. But instead of using the LLM to do the classification and say, guess what is this domain name is about, this one downloads the first page of a certain website or various other pages, because we have the data. And now I'm asking to LLM, now try to classify it. Okay, most of you are Spanish. I'm not Spanish. But this guy was able to understand Spanish and to report a classification in English and report everything in English. So you also have the ability of classifying languages that are not your Latin languages. So for instance, imagine that this domain name was Indonesia or Japan or China. I have no clue what's written on that thing. Probably looking at the picture, I can try to imagine, I can try to guess what's behind it. But I believe that the power of LLM, okay, is very useful. And I believe this classification is much better than this, I hope, right? So what I'm saying is the following, just to wrap up. You have to know your network. Most of the things are done today are done by hand, unless you are talking about automation, so we've seen a great presentation before. But I'm talking about the traffic, what is passing inside the network. Okay, so we need to be relaxed. Okay, so I hope that in the future, the computer is telling me there is a problem, but this traffic is from a website, from a domain name that it probably looks good. Don't care. The students are playing. That's fine. Not a problem. Or you say, okay, no, there is something wrong behind this, because for some reason, don't forget that Mistral was trained on a lot of data. Okay. So if he sees something wrong, say, triggers an alert and says, okay, now try to look at these machines, because there is probably something that requires your attention. Okay? I'm not saying that this will be completely correct, but I believe this one is not too bad. It's the same operation that a human will do, a human with experience will do. So imagine how you can apply this to alerts, this LLM to alerts. So to correlate the dots, okay, and try to have a response that allows you to focus more on what you have to do instead of focus on travel. And then just to complete, if some of you is living in Madrid and likes Suricata, the IDS, will be there. We'll present this DPI thing integrated with Suricata in 3 weeks, let's say. That's all. Thank you very much. This is the GitHub hook, so in case you want to see the software. Thank you, guys.
¿Alguna pregunta? Questions? Yeah, pictures? No one? No? No preguntas? So thank you so much. It was a pleasure.